Let's begin a brief critical review of the state of educational research. Educational research is a branch of social science research which tries to emulate the rigors of physical science research. So, what is scientific research? Well, it's a system of building knowledge through systematic observation, experimentation, logic, and an agreed upon methodology. Now, these two Nobel Prize winning scientists have a slightly different take on it. They talk about it being a search for truth and knowledge in an exponentially expanding frontier of ignorance. Think of blowing up a balloon. The air that goes into the balloon is our increasing knowledge, but the surface of the balloon exponentially increases as it grows, and that's the frontier of our knowledge. So there's lots to do in scientific research. Now, let's compare science with another discipline that you know, which is mathematics. Mathematics is concerned with proof, and let's give an example of that. So, let's prove that angle 2 is equal to angle 7. Now, we can do that without measurement and without experimentation, solely through logical proof. Okay, so given these two lines are parallel, because of that, we know that angle 2 is equal to angle 6 because we've already proven that corresponding angles are equal. And that angle 6 is equal to angle 7 because those are vertical angles, and that's already been proven that they are equal. Because 2 is equal to 6 and 6 is equal to 7, therefore 2 is equal to 7 because of something we call the transitive property, which has been proven. QED, angle 2 is equal to angle 7. It's proven, it's known, period. There is no argument and can be no argument. Let's compare that to science. Science doesn't do proofs. What science attempts to do is gather evidence to reduce uncertainty and error. Now that may sound like, gee, that's not how I think of science. But by example, this crazy formula is the fundamental formula of science. It says that variable x is related to variable y. And as we change variable x, that causes a change in variable y. And let's have a quick example of that. So let's say we want to examine how many Chinese words can we learn in one course of introductory Chinese. Okay, so let's say that our x is that we have 30 class sessions to learn this. And we're using a curriculum that teaches 10 words per class. Okay, so our fundamental relationship is with 30 classes, we can learn 300 words. But some kids all come in already knowing some words, and maybe they grew up in a Chinese-speaking family or with a Chinese neighbor. So there is a factor that says, well, some kids may add words to their knowledge. Maybe a kid is absent for 2 classes, so this alpha would subtract from the total number of words. Okay, so that's fine. But what's this E? The E is error. Error is built into every, without exception, every science experiment. So it's the uncertainty, the error, the change in the difference in instructor, the difference in students and how well they learn, how much sleep they get, did somebody's girlfriend break up, whatever. So let's explore this further. What kinds of questions is educational research expected to answer? Here are 3 of them. So imagine you're a high school principal and you're told you need a policy on social media. So you want to see, well, what does the research say? Do other high schools ban social media? Or we need a new biology textbook. So maybe there are 5 of them on the market, but which one should we purchase? Uh, and we want to start teaching Mandarin Chinese next year, but do we teach it by conversation or by a reading and writing approach? Which will be better? Well, those are 3 different kinds of questions. So the one about social media and cell phones is on today's common practice. It's a policy question that tends to be a short-term policy question. How about which curriculum materials should we buy? In this case, we're evaluating a commercial product. So we can't decide, oh, well, let's have a little more of this or a little less of that variable. The commercial products are this one or this one or this one. And that has to do with an issue of purchasing. We have only so many choices. Which one should we take? We're not going to mix and match, probably. And then how should we teach? Finally, we get a question that has to do with pedagogy on how do students learn best. So let's look at those in greater detail. Each one has a certain scope and a certain kind of error that is related to it. So our policy research has a scope of high school in Pennsylvania. Okay. And in it, how do we conduct that? Well, a survey is conducted. And in this case, a survey was conducted that was in a dissertation. And I was a committee member on this, so I'm party to this. So the dissertation is the perception of teachers and administrators. So no experiment was done. There was no control group. No tests were administered. Instead, it's all about opinion and the current practice of high schools. Surveys were sent out. Some were returned. Some chose to participate. Some teachers and administrators chose not to participate. They were too busy. They didn't care. They didn't have an opinion. So right away, the sample is biased. But we know that. So there's a relatively large error term in this particular study, and the scope is small. Maybe from the research value would be useful for maybe up to 3 or 4 years from today. Okay, let's look at product research. In this case, one of the best current studies was by the U.S. Department of Education, its Institute of Education Scientists, and back around 2003, they decided to do a major nationwide study, random assignment of treatment groups, control groups, treatment groups. It was fantastic. What they wanted to do was they selected the 16 best respected reading and mathematics software, and they wanted to see which ones work best. So these were randomly assigned. The treatment groups were all teachers who had never used this before, so they were comparable in a sense. And the study was given to a wonderful group, wonderful research team led by Campuzzo to study. What did they come up with? After the first year, there were 0 products that significantly impacted student gains. Based on that result, 1/3 of the companies pulled their products out from the study. They didn't want truth. They didn't want to know what's good and what's bad. They wanted marketing material that says their stuff is great. If they couldn't have that, they took their marbles and went home. In the second year, they found exactly 1 primary reading product that helped a little bit. And then the study ended. They didn't even do the 3rd year. So the scope here is U.S. schools. The error goes through the roof. Not because of Campuzzo and her colleagues. They did a fantastic study. But the study asked, to what degree does reading and math software teach? Which ones teach better? And it turns out that reading software and math software, in this case, don't teach. The teachers teach. So the actual study was constructed in a way that guaranteed massive error and that its results were useless. Well, how about a pedagogical study? Let's have a hypothetical study of our Chinese teaching methodology. So let's say we have randomly assigned groups. Some teachers will already be very fluent in Chinese. Some were born with that as their native language. Others just got certified and are pretty rusty. It's the first time they've taught. Some students grew up in a Chinese-speaking atmosphere, maybe in Chinatown in New York or San Francisco or Boston. Others have never heard a native Chinese person speak. So they're due to multiple complex variables. In this case, the scope could be global. How do students best learn a foreign language? But the error is massively difficult to control. And as we look at scientific studies, we need to keep these issues in the back of our mind, that good science is hard to do. So reflecting on our science research being a search for truth and knowledge, but for what purpose? What are the goals? Truth and knowledge, that's nice, but one goal is for an accurate description of reality. So our survey for Pennsylvania high school's use of social media wants an accurate description of today's reality for school policy. It doesn't say it's a permanent reality. It's useful, but it's of short-term use. How about to understand cause and effect? Well, cause of Mandarin Chinese being taught conversationally versus through reading and writing will most likely have an effect on how well students learn. Of course, how do we test that? So conversational teaching will probably give conversational ability that reading and writing study won't get. But maybe those reading and writing students can read and write better than the conversational students. How about predicting future outcomes? Prediction is one of the core values of what's good scientific research, good theory versus not so good theory. If it has predictive value, it's great. If it doesn't have predictive value, meh. So far, our educational research has not been very good at predicting the future increase of, like, how do we improve student achievement? And that's a core thing for you to think about as you look at scientific research. And finally, what in education actually is amenable to scientific study? Some things are, some things aren't. To the degree that we study groups, can we apply that to individual students, or is that inappropriate? So enjoy. So I hope this review has helped you look at educational research through a critical lens to realize how hard good research is and to see which studies seem to have good predictive value and which may have none.